Okay, I have been asked to go over the exponential regression application problem. That's one of the last couple of questions in section 5.4. So let's go and take a look at that. Let me go ahead and share the screen here. That. All right. So 7 and 8, the last two questions in this set are really this same problem, just giving you another practice by changing the numbers. So if you look at it, we have information that shows the personal income as the Y value and the years as the X values. And it says in the definition that it represents total personal income of the country in billions. So that's our Y values for selected years from 56 through 2001 in the table. When you get to part A, though, where it actually asks you to do an exponential model, that's where you'll have to use your regression features on your calculator or Excel or Desmos, whatever you're using to do your regression. And it says write the equation of this function with X as the number of years after 1956. Okay, so that implies that we're going to need to realign our X values. So the X isn't the entire year, but it just measures how much time has passed since that start year. So the first 3 years are 1956, 66, 76. The 1956 start year is what we'll call the X value of 0. So then the next couple of years, 66 and 76, the X value will be 10 and 20, because that's how far after 1956 those years are. So we have to realign our data when we put those in for list 1. So let me go ahead and go to the calculator so we can take a look at that. Stop this one and share the calculator. Okay. So we're going to go to the stats area of the calculator. So let's do that. We'll do stats. Microphone a little closer. All right, so we're going to stats edit when we put things into the calculator. And you can see that, just kind of in the interest of time, I have already put these numbers in, but that 0, 20, 30, 40 was from 1956, 1966, 1976, and so on. And there is just a little 5-year gap between the last one. I think it goes from so what is it, 50, 60, 70, 80. It goes from 96, and then the last year is 2001. So they only did a 5-year hop between this last 2 years. So that's why it goes from 40 to 45. And then the numbers on the right are just those income values exactly as they were in the table. And remember that these represent billions of dollars. Okay, so if I wanted to know what the standard number for this is, I'd take that number and multiply it by a billion, move the decimal 9 times. Okay, so we have the information in there. So to get the model, if we go back to our main screen, we're going to start again from the stats menu, and this is the calculation that we'll do. So we go right arrow to calculate, and we hunt down where it says exponential regression, which is the 10th one right there, EXP. So let's go ahead and select that. I'll go down to calculate, and then I will round the values to, I believe this asks for 3 decimal places. So I'm going to, at least when I looked at the example, it was 3 decimal places. So this would be the most exact values. If I wanted to use the A and the B, I could use the feature that assembles the model for us and drops it into Y1, but they did ask us to round it off, so I'm going to go ahead and round these off. So the first number, if I look at the decimal place, it's decimal 9600. So to 3 decimal places, that'll be 441.960. The B value, 1.07, and that 6 will bump up to a 7. This is followed by a 5. So I will put those two together where I multiply the B value, that 1.077. I don't multiply it, I will raise it to the X power, and I will write all that into the Y1. So that's what I have right here. 441.960 times 1.077 to the power of X. That's the model that it showed us when we were on the main screen there. I'll show you again. The very top line shows you how to put those two numbers together. And then that's what I've done. And so now I have it stored in Y1. So that is how we answer the first part of the question. So let's go back to the question. Let's see, it says 3 decimal places as needed. Okay, so it was, I have already forgotten. Let me look it up again. Okay, it'll be 441.960, 441.960 times 1.077 to the power of x. That's where the x goes. So there are my two A and B values rounded to 3 decimal places. Let's see if that's okay. All right, part B. Now it just asks us to use it like a function now that we have it stored in our calculator. So the country's total personal income in 2006 will be blank $1 billion. So notice the units on that box are billions, which is the same as the unit in the definition. It says personal income of the country in billions of dollars. So all it really wants is a Y value that goes with the X value that's associated with the year 2006. Okay, so if we just kind of look at our table, the last year we were given was 2001, and we knew that corresponded to 45. So 2006 is just 5 years after that. So this will be in year 50. That's 50 years from 1956. So we're just going to plug 50 into our function. So back to the calculator. So I'm going to plug 50 into this function. And there's many ways that we can do it. I already have it stored here. So what I can do is I can do this on the table or different areas. I'm just going to go and use the function symbols that our calculator has. So that's if you hit alpha trace, you get a list of all the function symbols. So I'm just going to select Y1. That's where I have it stored. Then you can just use function notation with your parentheses, put your X value in there. And that's going to be the answer to the first question. 18,037. 18,037. I don't know how many decimal places it wants. So I'm going to write them all down and go back to the homework. We're just plugging in 50 there. So let's do that here. Down to 3 decimal places as needed. So it was 18,037, 18,037 decimal point. And then it's 1588. So that will round to 1, 5, and 9. Okay. And then this is the only one that's a bit tricky. And I put this in the pop-up message that pops up for this to remind you how to realign your data. It says the total personal income will reach 21 trillion in what year? It says round up to the next year. All right, so it means when is the output going to be 21 trillion? Now remember, these are in billions, and then the last one we have in our table is 10,000 and something. So the 21 trillion is like 21,000 billion. So I'm really going to have to change my unit so that I'm looking for an output of 21,000. So let's go to the calculator one last time, and we can solve this algebraically, or we can solve it using some graphing techniques. So I might do a graphing technique here. Let's look at, I don't normally turn my plots on all the time, but I'm going to do that so I can do one of those quick zooms. So when you do a zoom 9, which is a zoom stat, it takes a look at the scatter plot and make sure and readjust the window automatically. So let's see how high up that goes. So the window setting wouldn't go much higher than our current maximum value. I want to see when this thing hits 21,000. So I'm going to increase my Y max to be sure that I can see a level of 21,000. So I'm going to set it at 25,000. And I don't know if my X value is going out to 50. Well, what was our X value? Our X value at 50 was 18,000. So it's not quite looking out in the future enough. So I'm going to change 50 to 60 right here. All right, so now I'm going to look at the graph. So there's that curve that's making the predictions beyond the last year that we have. Somewhere over here, we're going to hit a height of 21,000. So if I want to do it, well, let's do the graph. I'll just hit the trace to remind you what we're looking for. You have to hit the down arrow to get on the curve. And I'm watching my Y values down here in the corner until it gets up to about 21,000. So it was in here somewhere. That's about 22,000. So somewhere in here, there's 20,451 and then 21,205. So it looks like the X values are somewhere in the low 50s, but I need to get a little more accuracy than that. So we can either set this equation equal to 21,000 and do our regular solving with logarithms. But since we're kind of using a lot of graphing techniques, I thought we would solve this one with graphing as well. So when you do that, you just treat each side of the equation like a separate function. So we'll put y2 equal to 21,000. And that will cut a horizontal line through our function. And we want to find that intersection point right there. The x value of that intersection point will be what is on the blue line that makes it hit 21,000. So we're going to do intersect. That is also one of the calculations over the trace key. So second trace, intersect is number 5. And then it asks us which functions are we working with. It asks from the top, is y1 or the blue curve one of the curves that goes through that point? So you just hit enter for yes. Is your second curve, look at the top, y2 equals 21,000, the red line. Is that another curve that goes through the point of intersection you want? And it is, so I hit enter for yes again. The guess, in this case, isn't important because there's only one point showing, but in theory, you would move your cursor closer to the one you're wanting in case there are two different intersection points showing. And once you click enter after the guess, here's what we've got. We've got, it is just a little bit over 52 years. And then that's when the value is 21,000. So the fact that it's just over 52 years, 52.05, I'll write that down so I can go back and explain why we're going to round this thing up. I think it probably asks us to round it up. Okay, so it says round up to the nearest year when the nearest year would be 52 because it's 52.05. But the reason that we're going to round it up is it says in what year does the model predict the income will reach 21,000 or 21 trillion, which is 21,000 billion. So it's going to reach 21 trillion somewhere after the 52nd year has ended, because it says 52.05. That means we have finished the 52nd year, which would be like what, 2008, I guess. And then it's going to go into the next year, 2009. Let me just. Am I off by a year? 1959 plus 53. I thought I plugged in 50 in there. Anyway, 1959 plus 53 years is 2012. So that's what we'll put in. Our final answer, 2000. I was off by 5 years. What did I do messing? In the near, what did I do? Let me go back and look at my calculator. See, what did I mess up on? 52.05. I put in 21,000. So that means it's in the 53rd year. So, oh, it was 56, not 59, Goober. 256, 2009. My bad. Let me go back to the thing I was looking at. All right. Yeah, I was off by 3 years. Oops. Now make sure you add it to the correct start year. I wrote 1959 instead of 1956. All right, so if you take 1956 and you add 53 years, that's 2009. All right, so that's how you do that problem. Realigning your X values to correspond to a start year is probably the most important thing to tune in on something like that. And make sure you round your values correctly. That's another place where you can get tripped up. And then usually there's a question where an input-output question. And if it's one where they give you something associated with input, just plug it into the function and evaluate it. If it's something where they give you an output, like this part C, the 21 trillion, representing an output of 21,000, the way that thing calculates, you could have to either solve it by hand with using logarithms, or you can do what I just did and do an intersect on the calculators. But anyway, that's how you get those questions answered using regression techniques. So I hope that is helpful, and I'm going to go ahead and stop sharing, stop recording, so I can go ahead and get this thing uploaded.